This video is about Introduction to Venn diagram. A Venn diagram consists of a universal set U represented by rectangle. Sets within the universal set are usually represented by circles. In Venn diagram, we have complementary sets. We use A prime to show that. That means not A. In the universal set, everything except this A, we call this is a complementary set. We have a subset. B is a subset of A, means set B is in set A. We also have an intersection. A intersects B. That is elements both in A and B. We have a union set. A union B, that means everything in set A and B counts. Also, we have disjoint or mutually exclusive set. There's no common in set A and B. We call A and B are mutually exclusive sets. First of all, let's talk about a Venn diagram with two sets. What the section with a different color means. The blue one means in A, not in B. So we can use A intersect B prime, means in A, but not in B. This color means in A and B. Therefore, we use A intersect B to show. For the green one means in B, but not in A. The set will be A prime intersect B. For the yellow part means not in A and not in B. Therefore, we can use A prime intersect B prime to show the section with a yellow color. For this Venn diagram with two sets, we use A, B, C, D stand for the elements in each section. In other words, the elements in A intersect B prime, that's A. Elements in A intersects B is B. A prime intersects B is C. And not A intersects not B will be this D. So we try to find how many elements in A. A will be the whole circle. Therefore, the elements will be A plus B. How many elements in B? B means the whole circle. Therefore, you could say it's B plus C. How many elements in A union B? That means everything in A or B counts. Everything counts. Therefore, you will get the A, B, C. You adding them up. Most of students made a mistake. They thought A is all the elements in A. No, the A means those elements in A but not in B. You have to really know this concept. Now let's talk about a Venn diagram with 3 sets. We have A, B, C set. So for each section, we use a different color to show what's the meaning for that. For this A, you could say it's in set A but not in set B or C. We have another word is only in set A. Therefore, we can use this A but not in set B, not in set C to show that for this A. For IB exam, sometimes they use only in set A to show this section, or sometimes they use the word in set A but not set B or C to show. For this B means in set A and B but not in set C, or sometimes they use only in set A and B. So if we want to use the set, that means set A and set B, but not in set C. For this C means only in set B, or you could say in set B, but not in set A or C. So we use set B, but not in set A and not in set C. For this white color in this universal set, that means not in any of 3 sets. So we can write down not in set A, not in set B, and not in set C. For this D means only in set A and C, or you could say in set A and C, but not in set B. So we can do A intersect C intersect B prime. For this G means in set C but not in set A or B, or you could say only in set C. So we can write C intersect A prime intersect B prime. For this E means in set B and C, but not in set A, or you could say only in set B and C. We can use B intersect C intersect not A to show this section. For this F means in all 3 sets. Therefore, we can use A intersect B intersect C. When you do the problem with 3 sets, you have to be careful with those words like only. It means a different thing. Without only or with only means different. Let's talk about the difference. Only in set A. That means the element will be equals to A. But when you say in set A, means everything in A that equals A plus B plus D plus F. You see the difference. So you have to be very careful. Only in set A means A but not B or C. But when you see set A, everything in set A counts. For this, only in set A and set B, that means for this B equals to B. But when you see in set A and set B, means everything in set A that circle and also in set B circle count. So we will get the A plus B plus D plus F plus C plus E. So you have to be very careful when you read the problem about the Venn diagram. When you see only in set A and set B, or in set A and set B, totally different. Same thing when you see only in set A, or you will see in set A, they are different. So pay more attention to the words when you're working on the Venn diagram. On separate Venn diagrams, shade regions 4. So we use shaded region to represent the sets. A is A intersect B intersect C. That means in all these three sets. That's why we shade this area. For B, A union B union C, which means in A or B or C, everything in B, A, C counts. That's why we shade area for all A, all C, and also all B. Let's go to C. Complementary set of A intersect B intersect C, which means we shaded everything except this section. That's it. For D, B intersect C. B intersect C will be this. Then union A, everything in A count 2. So you will keep going. We see everything in A. Let's go to E, A prime, which means you will shade everywhere except the set A. Now we will circle this set A. When you draw the shaded area, we don't touch that A. Now let's go to F. A union B intersect C. First of all, we do A union B first because this is in the parentheses. So we do A or B. Then it said intersect C. So we need something in common. I will draw the C this way. And these two lines overlapped will be the answer. In other words, I can do this. This will be the answer. In other words, this will be the answer for A union B and then intersect C.